So welcome back students to one more session of your structure of atom. So I think our journey is going on regular basis. Hope you're all watching it on a regular basis and noting it in your book. So last time when I've done with, when I had classes with grade 12 students, I asked them to take a long register, name it as World of Chemistry as that particular register name, and start noting all the topics. So I request even the grade 11 students to do the same, so that you'll have a separate notes for your grade 11 chemistry. So here in structure of atom, what topics did we discuss till now? Let's see. I've given you the index. Yes, I've taught you about cathode rays, anode rays, and discovery of neutron. After that, I gradually went into a topic called atomic models. In that, what did I teach you? I've taught you J.J. Thomson's model as well as Rutherford's model. Now today we'll be gradually going into the numerical part of the chapter. Very basic thing which we are going to do today, and we'll be solving, as I promised, I'll be solving the NCERT questions as well as comprehensive questions also. So the topic of study today is atomic number and mass number. The same thing you've studied in your grade 10th also, isn't it? In grade 10 NCERT you've studied this concept. Okay, let us repeat it once again and do some numericals related. So whenever we speak about atomic number and mass number, the first important thing, what are the subatomic particles which we have studied? We have studied atom contains protons in the nucleus. Atom contains electrons which are revolving continuously around the nucleus, and you have a neutron which is neutral in charge. Yes, and unit, listen, yes, so neutral in charge. Okay, let us not write this and not. So neutron which is present in the nucleus. Now in relation with all the three, we have, or we are going to learn a concept, that is atomic number and mass number. So basically, whenever you are speaking about atomic number, mass number, first we are going to take an element. Let us assume the element as X. Suppose if I take an example here, let me take carbon. Now X is the element, here carbon is a specific example of the element. Always remember, atomic number is written at the base. If I have to speak about the atomic number of carbon in the periodic table, it is 6, isn't it? Hydrogen, helium, lithium, beryllium, boron, carbon. So 6 is the atomic number. Above that, just above that is written the mass number. Mass number is always double of the atomic number, 12. For some few it is not double, right? That also we will learn. 12, done. What does this atomic number indicate? Fine. So atomic number is always equal to number of protons. We very well know protons are always equal to number of electrons. Then only the electrostatic force of attraction is able to it will maintain that force of attraction. So number of protons is equal to number of electrons. This is your atomic number. Now what is mass number? Mass number is equal to number of protons plus number of neutrons. Remember this. Fine. Apart from this, okay, protons I can easily say. Let us come back to this and solve this. Atomic number I've learned, mass number I've learned. I should also know what actually is, where should I calculate the proton, what should I calculate the electron, isn't it? Now let's see. Now how many protons are there in this? How many electrons are there in this? How many neutrons are there in this? For knowing the protons directly, you should go. So I said atomic number is equal to number of protons. So here the number of atomic number is 6. So the protons are 6. Here in this case, when protons are equal to electrons, atomic number again, electrons are also 6. This indicates your protons equal to electrons. Now, neutrons. How will I get neutrons? Right? So simple, isn't it? Neutrons, how do you calculate? It is the mass number minus atomic number. This is your mass number minus atomic number gives you neutrons. How much is it equal to? 12 minus 6, that is 6 neutrons. All are equal in carbon. Yes, once again, simple. Element is denoted as X. Atomic number is denoted at the base. Mass number is denoted at the top. Atomic number is always equal to protons. Protons are always equal to electrons. Simple. After that comes your mass number. Fine. So what is mass number? Mass number is nothing but protons plus neutrons. If I have to calculate individually one after the other, proton, nothing but the atomic number. Immediately electron, again nothing but the atomic number. Now comes leftover is neutrons. Neutrons, how do you calculate? You subtract the mass number with this atomic number, you will directly get the neutrons. Okay, little bit confusion. Let us solve a numerical and see how to go about. Here in this question, it's a comprehensive question which I've picked up. Then gradually we'll go into the NCERT questions. Here they've given me calculate the number of electrons, protons and neutrons. Directly, simple question. So they've given us two species. What are they? One is phosphorus, one is P-3 phosphide ion. Done. So for this first thing, let us take the first example, 1531. I need to find the electrons, protons. That is right. So number of electrons. How much? Your concentration should go here. The first one, atomic number. How many electrons are there? 15. Number of protons. Immediately, as electrons are 15, protons are also 15. I need to find number of neutrons now. Number of neutrons is how much? What did I say just now? It is mass number minus atomic number. So mass number minus atomic number, 31 minus 15 is 16. 16 neutrons. This is how we are going to do. Let us do the next one and see what is this given to us. They've given us P minus 3, 15, 31. Here you need to be careful. What is the concept? Now, here there is excess amount of charge present around the element. Right? Minus means excess. Plus means reduction, less number. So how much is the charge excess? 3 electrons are excess, not protons, electrons. So always remember you need to add 3 electrons. Why? Because phosphorus is this phosphorus 15 is a atomic number which is equal to the number of electrons plus 3 electrons. So the 15, 18 electrons are there. Nothing to do with the protons. You'll add, because electrons keep adding to the outer shell, you'll never add the electrons into the proton, into the nucleus. They keep adding to the outer shells only. So 15 plus 3, 18 electrons. So let's write. Electrons is equal to 18. Now, how many are protons in this case? 15 only. Nothing changed in that. Now, how many neutrons are there? Neutrons is equal to mass number minus your atomic number, which is equal to 16. So, this is the case. Now, let's see the difference. 15, this has become 18 because the electrons have added to the outer shell. Next, 15 is the same. Okay, 15 is the same. I'm sorry, I should not write this. 15 is the same. Next comes 16 neutrons, 16 neutrons. Only difference is you need to see the charge and add it to the electrons only. Right, now let's come back and see one more question based on calculation of number of electrons, protons and neutrons. But here a bit different question is given. Let's solve this. What do they give us? The number of electrons, protons and neutrons in a monoatomic species. Okay, they've given us a clue that there is a monoatomic species. Fine. So I have equal to 36, 35 and 45 respectively. Assign the proper symbol. Okay, here they've given us the electrons, protons and neutrons. I need to assign the symbol. So what actually are the clues? Let's see. First they've given us electrons is equal to 36, your protons is equal to, let us write the full form which is given. Electrons is 36, protons given is 35 and neutrons given to us is 45. This is what is given. So one clue which they've given, monoatomic. Fine. So from this data what can I write first? First of all, I need to know the symbol of the element. Now see. What did I say? Atomic number is equal to number of protons, which is equal to number of electrons. So always remember, electrons keep adding. See, whenever you're adding an extra thing, electrons keep increasing, but protons will never change. So the first indication is you need to see the atomic number in regard or in relation to the protons only. Don't go with the electrons, right? Electrons, as I said just now, they may keep changing because they may get added outside from the outer shell. So the first, what are the number of protons? 35. So number of protons 35 means the element with atomic number 35 is bromine, isn't it? So bromine is element now, capital B, small r. So number of protons 35. Done. Now next I should know atomic number is known to us. I should know the mass number. So what is mass number? I already said mass number is equal to number of protons plus number of neutrons, isn't it? This is what we have written. So what is the number of protons given? 35. What is the number of neutrons given? 45. So mass number 45 plus 35, it comes to 80. So I've got the mass number is 80. But now what is the difference here? After writing the symbol, now I have to check whether it is a monoatomic element or not. Yes, it is monoatomic. There's nothing, it is not diatomic like, H2 or something like that. So it is monoatomic in nature. Fine. So now what is the extra electron? Electron, one electron is extra. That means I need to write a minus symbol here. Okay, simple. Let us come back and cross check. 35 protons, correct. 36 electrons represented, number of neutrons of 45. So if I subtract 80 minus 35, I get automatically 40, isn't it? Yes. So this is your mass number which I have calculated, 45 plus 30. Okay, let us write number of neutrons also. I will write, how can I write? Mass number minus atomic number. Mass number 18 minus 35, it comes to 40. So all the things together valid. So this is how we are going to do. Let us come back and do one more numerical. Right. Let's come back and see one more numerical. Here they've given us 4 different examples, so that's the concepts are clear. Now here what do they give us? Complete the following table given. They've given us 1, 2, 3, 4 examples. Again it is a comprehensive question. Let's see. So now zinc is given, mass number is given, atomic number is given. I should find out the protons. Just see, number of atomic number is always equal to the number of protons. 30, done. Here there is no charge, nothing, no plus or minus given. So directly I can write the number of protons equal to number of electrons. 30, done. Here in the second case, I need to find all the 3. Atomic number, here there is a charge given. You have to be careful here. Now atomic number, again the same protons, but here there are 2 electrons less. So at 30, this becomes 36. I've reduced 2 electrons because it has lost 2 electrons. Now what is number of neutrons? Mass number minus your atomic number. Yes. So when I get this, I get 54, isn't it? 52. 52. Yes. 10 minus 8, 52. So this is how we're going to do. Now neutrons we have not written here. Let us write. So again 64 minus 30, this becomes 34. So simple. Go with atomic number, write the number of protons. If there is no charge, directly write the number of electrons. Now neutrons, mass number 64 minus 30 here. In the second case, protons are equal to the atomic number, but it has 2 electrons lost. So 2 electrons less. I need to now calculate the number of neutrons, mass number minus the atomic number, 52. Done. Now let's come back and start. Here what did they give us? Here they've given us to calculate the mass number. In this case again atomic number. So what is mass number always equal to? It is nothing but, when I've already told you, it is an addition of your protons plus neutrons. So protons plus neutrons, this comes to 43 plus 56, it comes to 99. Now second thing, I need to write atomic number. Atomic number is always equal to number of protons, so it is 43. Now again there is no charge on technetium, so the same number of atomic number equal to 43. Done. Now let's see this. Now when I have to speak about this one here, bromine, there's one charge present here. You have to be careful in this case. Right. So here there's one extra charge, that is 1 electron excess, isn't it? Yes. So what is mass number? I said it is right. Mass number is equal to number of protons plus number of neutrons. So proton, how can I know the proton? There is no proton given to me. So from the electron I can take it, isn't it? But here there is 1 electron excess. It is 36. So proton will be exactly, because 1 electron excess, but proton will be the same. So proton is 35. Done. Yes. Now atomic number equal to proton, 35. Done. Now mass number, add. Now mass number is nothing but the proton plus neutron. 5 plus 4, 9. 4 plus 3, 7. This is how you're going to do. So simple, isn't it? Understand the concept. The formulas are important. Right? So simple. Calculate. Always remember atomic number equal to proton. Proton equal to electron. But electron may vary. Second important thing, mass number is equal to neutrons plus protons. So according to that, I fill the table. So let's come back and do some more NCERT numericals now. Right. Now let's come back and solve one more NCERT question which is related to your calculation of number of electrons, protons and neutrons. Now let's see the question. Here what do they give us? They've given us calculate the number of electrons which will together weigh 1 gram. Okay, I need to calculate the number of electrons present in 1 gram itself. Next would be calculate the mass and charge of 1 mole of electrons. Fine, I've written the answers here so that I can directly write, but we will do the procedure first. So first of all, let us solve the first one. And for such things, basic, the standard values you should know. What are the standard values which you should know? I'll be doing it one after the other. First, so calculate the number of electrons which will together 1 gram, isn't it? What is mass of electron? Mass of 1 electron. Right, it is equal to 9.11 into 10 raised to the power of minus 28 grams, or it is 9.11 into 10 raised to the power of minus 31 kg. But here they've asked me to calculate in 1 gram, so I don't need this value, I need only this value. Right, so now next come back. Mass of they have to calculate number of electrons in 1 gram, isn't it? So write down number of electrons in 1 gram. Okay. Right, I need to calculate number of electrons in this one. So number of electrons present in 1 gram I need to calculate. Just multiply 1 into again this one, not a problem, divided by 9.11 because gram and gram should come below, into 10 raised to the power of minus 28. This comes to 1.0976 into 10 raised to the power of 27 electrons. So in 1 gram, so many electrons are present. So they've asked me to calculate number of electrons. So I've written number of electrons in gram and gram coming down. Let us do the next one. So in the second case, what did they ask me? Calculate the mass and charge of 1 mole of electron. So what is 1 mole equal to? 1 mole is nothing but Avogadro number, which is equal to 6.022 into 10 raised to the power of 23 electrons in this case. Yes. So they've asked me to calculate mass. So what is mass of 1 electron? Mass of 1 electron is 9.11. Now, here they've not mentioned any gram, isn't it? So I'll directly write the kg part. 9.11 into 10 raised to the power of minus 31. So 1 mole of electron means, so this is the basic thing. In 1 mole, how many are there means? Into 6.022 into 10 raised to the power of 23. Isn't it? When I solve this, I get an answer of 54.86 into 10 raised to the power of minus 8. That's in grams. If I have to convert it into kg, shift the decimal, 5.486 into 10 raised to the power of minus 7 kg. Now I need to calculate the charge. What is the charge of an electron? We've already studied. Charge of electron is equal to, we have studied this in E by M ratio, isn't it? 1.602 into 10 raised to the power of minus 19 coulombs. Now I need to find it in 1 mole of electrons. So 1 mole of electrons means 1.602 into 10 raised to the power of minus 19 coulombs into Avogadro number. How much do I get? I get an answer of 9.647 into 10 raised to the power of 4 coulombs. This is the thing. Simple, nothing. 1 mole I know. They've given me, I know the mass of electron. Together, how much is that? I've multiplied it. Charge I know. I know what is 1 mole equal to. Together multiplied, I got the number of electrons. Simple. Right, let's come back and do one more numerical, which is again your NCERT question. Here what do they give us? They've asked us calculate the total number of electrons present in 1 mole of methane. So basically 1 mole of methane they're given. So let us start solving it. First of all, the basic, go with the standard always. What is 1 mole equal to? 1 mole is equal to 6.022 into 10 raised to the power of 23 particles. Okay, right. Okay, let us write number of electrons they've given. So here electrons. Particles can be more electrons, ions, isn't it? Fine. So now, what do they ask me? Present in 1 mole of methane, they said. What is 1 mole of methane? 1 mole of methane means the molecule. How many molecules are present in this, isn't it? Now, carbon is how many? How much? It is 6 plus 4. It is equal to 10, isn't it? The methane molecule has 10. So now just multiply with this. So basically 1 molecule, let us write. So this is better. 1 molecule of methane is 6 plus 4. 6 from carbon, 4 plus from hydrogen. Now just write 1 mole is equal to 6.022 into 10 raised to 23 into 10. This comes to 22 into 10 raised to 24. So what is that? They've asked us calculate the number of electrons. So electrons. This is your concept. Right, let's come back and solve one more NCERT numerical. Let's read this. What do they give us? Find the total number and total mass of neutrons present in 7 milligrams of carbon-14 and assume the mass of neutron as 1.675 10 to the minus 27 kg. Now, first of all, I need to find the total number. So let us solve the first part. Now basically, what did they give me? They've given us carbon-14. It is not carbon 12. Basically carbon 12. Normally when I write it is carbon 6, mass number 12. Isn't it? So this particular thing has how many number of neutrons? It is nothing but equal to Avogadro number, isn't it? So let us start from here. Here they've given carbon 14. So carbon 14, so atomic number 6, right, has how many? Has 6.022 into 10 raised to 23 particles. Okay, let us write particles now. But here there is a difference in neutrons compared to the earlier one. Earlier it is 6 and 12. So the difference is 6. But here it is 14 and 6. So how many should I are there extra? For 8, there are 8 neutrons which are there. Right? So how many particles will be there? It is nothing but it is multiplied by 6.0 to the 10 to the 8. That. So here, what did they ask me? They've asked me for 7 milligrams. So this is 6.022 10 to 23 into 8 neutrons, isn't it? So they've asked me for 7 milligrams of carbon-14 isotope. So what did we write for 1 mole? That is for C14. I'm writing for C14. It has 6.022 into 10 raised to 23 into 8 neutrons. So this 1 mole has how much weight? It is nothing but 14 grams. 14 grams is this quantity. So many neutrons. Now how many did they give me? 7 milligrams. I need to convert milligrams into grams now. So multiply 7 into 10 raised to minus 3 grams. 7, it contains how many neutrons? So this comes to 7 into 10 raised to minus 3 into 6.022 into 10 raised to 23 into 8 neutrons divided by 14 gram and gram. I get an answer of 24.088 into 10 raised to 20 neutrons. That's over. I found the total number of neutrons. Now let us come back to this. The total mass of neutron in 7 milligrams of carbon-14. Assume the mass of neutron is 1.67. Right. So mass of neutron is 1.675 into 10 raised to minus 27 kg. Right. So 24.088 mass of 24.088 into 10 raised to 20 neutrons is how much? Yes. So cross multiply this. I get, when I cross multiply, that is 24.088 into 10 raised to 20 into your 1.675 into 10 raised to minus 27 kg. I'll get an answer of 4.034 into 10 raised to minus 6 kg. That's it, right? Simple, isn't it? First see what is given to you, right? See what is surplus, how much is extra, then go back to the numerical and solve that. And next they've asked me to find for so many neutrons what would be the mass. Now, let's see here, find the total mass. Right, so let's come back and do one more numerical. That's in your NCERT numerical. Let's read this question. So there's one more numerical after the previous lesson, that is, see, I've solved it with neutrons. You're supposed to solve it with protons, the same concept. But there they've given you to assume the mass of neutron. There they've given you to assume the mass of proton. Please try the numerical, same in relation to the earlier one. Now let's read this question. write the complete symbol for the atom with the given atomic number. Okay, Z and atomic mass. They have given us the atomic number and the mass number given to us. So atomic number represented by Z and mass number denoted by A. So already you would have learnt the periodic table, isn't it? Periodic elements 1 to 30 are compulsory for you all. Fine. So we very well know when the element is given. You can easily see 17 atomic number element is chlorine. 17, mass number 35. You just need to write the symbol, that's it. Fine. So next one. The element with 92 atomic number is uranium. So 92, mass number 233. And Z is equal to 4. Hydrogen, helium, lithium, beryllium. So the last element is 4, mass number 9. So they want you to write the symbols of the given examples where the atomic number and mass number is given to you. Right. So one more NCERT numerical, which is based on the calculation of number of electrons. So here what do they give us? Which of the following are isoelectronic species that is having the same number of electrons? So basically isoelectronic species will have same number of electrons but atomic number will be different. Remember that. Let us write isoelectronic species will have same number of electrons, but what is different? But different atomic number. Right, let's start with the first one. Now Na, take the ion given, write the atomic number 11. Fine. So there is 1 electron less, plus means less, 10 electrons. Potassium, second one, it is K plus. So atomic number 19, 18 electrons. Magnesium, it is Mg plus 2. It is atomic number 12, 2 electrons less. So 10 electrons. Next one, next set. Fourth one, calcium is, okay, calcium plus 2. Atomic number of calcium is 20, 2 electrons less. So 18 electrons. Fifth example, sulfur, minus 2. Sulfur atomic number 16. Here there is excess of 2 electrons. Remember that. 16 plus 2. This is 18 electrons. Sixth case, argon. Argon number, helium, neon, argon, isn't it? Yes. So 20. So argon atomic number is 18. So there is no charge. It is an inert gas element. So 18 electrons. Now they are asking us which are isoelectronic species. Now you have written based on the atomic number you have calculated. So sodium has 10 electrons. Magnesium has 10 electrons. So the first answer is sodium, Na plus and Mg plus 2 are isoelectronic in nature. The next set. Now let's see. 18 electrons, one set, 18 electrons, one more set, 18 electrons, one more, 18 electrons, one more. So the leftover potassium, calcium plus 2, sulfide minus 2 and argon are isoelectronic in nature, right? So this is the combination. Simple. Take the atomic number, see the charge, find out the number of electrons and finally write it to separate answers.